Hey everyone, I'm here to talk about our paper today, which primarily deals with medium field interactions. So, let's get right into it. Medium field interactions are defined as any interactions that occur between 1.5 and 30 meters, and while traditional direct manipulation techniques are effective in near field scenarios, they often become impractical or inefficient when applied to medium or far field tasks. This is mainly due to increased hand jitter, possible poor vision, and impaired depth perception. So, to address these challenges, novel interaction techniques have been developed and refined over time with the goal of offering distinct advantages depending on the task and context. These techniques include controller based methods and gaze based interactions, both of which aim to enhance the user's ability to accurately and efficiently interact with distant virtual objects. In the raycast based controller technique, the user uses a handheld controller directing an emerging ray towards objects of interest. The participants then use this ray to select and manipulate objects using the trigger and bumper buttons. While in eye gaze plus pinch based techniques, the user directs their gaze towards an object of interest to select it and then uses a pinch gesture to manipulate the object. Slight variations within these techniques often exist depending on the implementation by different developers. These techniques have been extensively implemented and can be found in AR and VR based games, and are also often used for UI navigation in AR headsets. The Meta Quest, Apple Vision Pro, and Magic Leap 2 all use some form of raycasting and gaze plus pinch for UI navigation. Another technique that has become very popular in academia for distant manipulation is worlds in miniature. There are several techniques such as voodoo dolls, Homer, that all work on a similar principle, which is allowing users to create a scaled down replica of either the entire virtual environment or a subset of the environment. These techniques allow users to interact with distant objects more effectively, bringing the medium field interaction to near field. They also address occlusion related issues that might exist. But a limitation that exists is that most of these techniques don't allow for fine grained control over the objects to be cloned, often using a predefined list of objects, a hierarchy of objects, or cloning the entire environment. To address this need, we conceptualized the Force, a VIMS inspired interaction technique which allows users to selectively clone distant objects using a cone like selector. You can see this cone with a blue outline being used to select the target dice and other objects. Once users are done selecting, they can spawn the miniature clones by making a fist and then using an open palm like gesture. Finally, users can then start manipulating these miniatures by directly interacting with them. With having designed this technique, we wanted to look at how the Force compared against the contemporary techniques such as raycast based controller and eye gaze plus pinch that were shown earlier. Did it provide the users with any benefits? Did it enable better interaction with such distant and maybe densely packed objects? We were yet to find out. So for this, we conceptualized a docking task where users were instructed to pick and place four distinctly colored target dice present among a densely packed volume of non-target objects to their corresponding color-coded pillars. Users were instructed to place the dice in the outline mesh present on the corresponding pillars and to match the orientation of the dice with the orientation of the reference dice present above the pillar. For example, the red dice would go in the black outline mesh on the red pillar with the number 4 facing forward. The outline meshes gave users a reference of the precise position and orientation the die needed to be placed in. The pillars were located on either side of the volume where objects were spawned. Participants stood within a rectangular area marked with hazard tape that was strategically positioned at one end of the room to provide users with an optimal viewing experience. They remained within this area but were allowed to move freely within the space when performing the task. They were given examples of permissible movements including bending down, standing on their toes, and walking around within the rectangle. This flexibility was intended to enable natural interaction with the virtual environment while maintaining a controlled study area. The study was within participants' design, where we manipulated the type of interaction technique used. Each participant experienced all three techniques, and a balanced Latin square design was used to minimize any order effects. For each technique, participants performed 4 blocks, each of which consisted of 4 dice placements, totaling 48 placements per participant. As you can see, in the raycast plus controller, the ray emerging from the controller is used to select and manipulate the target dice, whereas in gaze plus pinch, the user's gaze is used to select the objects of interest, while a pinch-like gesture is used to manipulate it. Lastly, in the force, a cone is used to select the objects, and once the miniature view is spawned, the miniature clones are directly manipulated, which in turn results in the manipulation of distant objects. In the end, we had 30 participants for our study, 10 of whom were female, 1 of them was non-binary, and the rest were male. Objective data on user performance on the task was logged. Both accuracy and efficiency were measured for each trial. Accuracy was measured using positional error and orientational error, which measured how off the users were in placing the dice from its designated outline mesh. Efficiency was measured using time on trial and working time. The former measured the time taken by the participant to complete a trial, and the latter measured the time they interacted with the target dice. Number of obstacles that the users interacted with while completing the trial was also measured. At the end of each interaction technique, users were also instructed to fill out the PSSUQ questionnaire to understand their perceived usability rating of these techniques. Based on our pilot testing and intuition, we hypothesized that the force would perform the best in both accuracy and efficiency, while also being rated the highest from a usability perspective by participants for this particular task. Moving on to the results, in line with our intuition, the force ended up being the most positionally accurate, where the error was significantly smaller in the force when compared to raycast plus controller and gaze plus pinch. For orientational error, the results weren't exactly as we expected. While the force did perform significantly better than gaze plus pinch, probably due to the users having the ability to view the target dice from different vantage points, it did worse when compared to raycast plus controller. Nonetheless, the relative superior performance of the force on our measures of accuracy offer partial support for hypothesis 1, indicating that cloning and manipulating miniatures of distant objects can enable higher levels of accuracy for medium field tasks. Looking at the time on trial, it seems that while the force may be accurate, it definitely isn't as efficient as raycast plus controller or gaze plus pinch, with users taking 5 to 10% longer to complete a trial. Now, where it gets interesting though is when we look at the time that was taken by participants manipulating the target dice. The amount of time spent manipulating the target dice was the least with the force than both the raycast plus controller and gaze plus pinch. Furthermore, the number of obstacles interacted with was also significantly fewer in the force as compared to raycast plus controller and gaze plus pinch. These two together indicate that there are inadequacies that exist in the force, mostly pertaining to the selection and cloning of objects, the stages before users can start manipulating them. This lines up with the user feedback we got while conducting semi-structured interviews, with users suggesting alternatives and improvements to the selection and cloning metaphor. All of this combined offers considerable support for hypothesis 2, indicating that interactions performed with the force can generally support increased efficiency. Lastly, while there was no significant difference between the usability scores of the force and raycast plus controller, or the force and gaze plus pinch, there was however a significant reduction in perceived usability in gaze plus pinch when compared to raycast plus controller. Hence, hypothesis 3 is not supported. With these results, there are some conclusions that we were able to draw. It seems as though the value of the force stems from participants being able to perform fine motor interactions on clones since they're situated in their proximate reach envelope, as opposed to having to work with objects in the distance, which naturally involve reduced visual acuity. One of the limitations to note with the force and gaze plus pinch is the presence of tracking error in vision-based hand tracking that exists today, which we believe led to higher orientational errors in both these techniques. With these observations and user feedback, there are several factors that should be touched upon next. The need for an improved selection metaphor is evident when looking at the disparities between time on trial and working time. Users also requested the ability to have two-handed controls of the clone, enabling them to scale them or add or remove objects from the miniature environment as desired. And lastly, Having compared these techniques in a docking task, we would naturally like to compare its performance against these techniques in other tasks, such as object assembly, path planning, and collaborative manipulation. With this, we come to an end. Thank you for tuning in, and this is the team behind the Force. Please feel free to reach out to us for any questions that you may have.